Hi, today we will go through an example of structure analysis using a method of join. So before we go to our example, we need to explain quickly how to analyze whether your trust is statically determined. So if you have a trust, so definitely you have a couple of joins and you have members. So in a case like in our example here, we have 7 members, that is in green, numbered in green 1 to 7, and we have 5 joins, the circles, if you can see that. And also in this figure 2, you can see we have 8 joins and 13 members in this one. So in a case like this one, we have a formula that is m plus 3 equal to g. So the number of members plus 3 equal to g. So in our case we have 7 members plus 3, that's 10, and 2 times 5, that is 10. So that satisfies what we just said. And this is also, you can use the same formula for a trust that is not yet on a foundation, so like this one in figure 2. So we have here 8 joins and 13 members. So if we say here the members is 13 plus 3 is 16, that's equal to 2 times 16. So it satisfies what we just said. In another case, if your truss is on a base like this one in figure 3, you use this formula, m equal to g. So the number of members equal 2 times the number of join. But in this case, you include this beam. If these beams, if the truss stand on 3 beams like this one, you count the 3 beams as well with the members. So if you count all this, you'll get 16 members. The join, you don't include the one in the base. You don't include this join. It will be 8. So the formula will be 16 equal 2 times 8. So also satisfy what we just said. Let's go now to our example. So in our case, we said m plus 3 times 2g. Okay, the 3 is the especially if you have a truss on a ruler like this and a hinge like this one. So you will have a reaction, vertical reaction like RD, and you have a reaction RA with 2 components, vertical and horizontal. So we need to solve for this 3 before we go and solve for the member forces. And we have here also W force going downwards here in joint B. So let's solve for these reactions. So we said the reaction RA, we have 2 components, horizontal component and vertical component. That's XA, YA transpose. So RD going up, this RD is going up here, equal 20. So we are taking moment. We said the moment is the sum of moment equals 0. So RD times 20 times the distance here. This is the 20, 10 plus 10. RD times 20 clockwise equal W times 10 cosine 60 here. This is the W. And because we know this is 10, but we don't know here the distance in 1. So we took the horizontal component of this distance, okay, 10. So we use 16 instead of 30. So we said we use 30, the angular 30. So RD times 20 equal W times 10 cosine 30. So from there we can find RD, which is 0.433 W. And W is the force that's coming downwards. Not downwards, but on an incline, this one. This is W. Okay, once we found RD, we need to find the vertical component. So the sum of forces vertical equals 0. So YA, which is the vertical component of our reaction A, plus reaction D, it should give us W sine theta, which is the vertical component of our force W, the force W. So we found YA equal 0.433 W. And we know also the sum of horizontal forces equals 0. So the horizontal component of reaction A plus W cosine theta, the horizontal component of the force, that is equal, that will give us XA equal minus 0.5 W. We got it minus because here we assume it is in compression, so that means it is in tension. We got it minus, that means it is in tension, not in compression. And as we said in the beginning, we are allowed to choose one, whether tension or compression, not to confuse ourselves. So we decided to take all the members' forces in tension, if you can see these green arrows. So we decide to make all of them in tension. So if you get it positive, we are right. If you get it negative, that means it is in tension, it is in compression, not tension. So we found XA here. This is the 3 component of the reaction we are looking for. After we do that, this is our M in the equation here we just said. We found the reaction, the 3 reaction. Now we need to find M. We have 7 members. In each member we have 2 forces. We need to find that, and some members we have more than 2 forces because we need to find the horizontal and vertical component. But we will show you that here. So force 1 in member 1 sine 30, that is equal to YA. So the vertical component of member number 1 plus the vertical component of reaction A equals 0. So that will give us force, the force of the member 1 equal minus 0.866 W. So again, that means it is in compression, not in tension, as we suggested in the beginning. Once we found force 1, we're still in joint A, so we have to find force 5. So that is joint 5 towards that is member 5 towards joint A, this one here. So we're looking for this one now. We found this one. So force 5 plus XA, which is the horizontal component of reaction A, plus the horizontal component of joint member 1 F1, which is F1 cosine 30 equals 0. That will give us force 5 equal 1.25. So that means it was in tension. Yes, it is in tension. We get it plus, not minus. So this, the guess was right. And we go to joint B here. So again, in joint B, we have to find again force 1 towards B there. And also we have to find 2 this one and 6 this one for joint B. We'll find it in the same way like A. So we know that F2 equal F1 because they are opposite each other. Once we found when 1 is going towards B, that means F2 is going towards B as well. So action and reaction. So that means force 2 equal minus 0.866 W. That means our case was wrong, so it is in compression, not in tension. So we go from B towards E. Force 6 plus W will give us 0. So this is 6. Show you, so it's easy. This is 6 going this way towards, and W going down, so they cancel each other. Okay, here, and that will give us force 6 equal minus W. So again, that means F6 wasn't in tension, it was in compression. We go to join D. Let's show you join D. So we go now here, join D soon, because we already know one force there. This is the reason we go there. When we know that, it will help us to find C. So you could ask yourself why we jumped from B to D, not going through C. So the sum of vertical forces equals 0. So force 3 sine theta, which is the vertical component of member 3, plus RD will give us 0. RD is the reaction going upwards and is going downwards. So that will give us the member force 3 in member 3 minus 0.5 W. Again, that means it is in compression, not in tension, because we assume all of them in tension. Again, the sum of horizontal forces equals 0. So force 4, it is already in horizontal, so we don't need to find the component. We are talking about the horizontal now. This one, we are in member 4 now, in joint D. Okay, this one. So F4 plus F3 cosine theta, which is the horizontal component of member 3, equals 0. That will give us a force 4 equal 0.225 W. So that means it was in tension, because we got it plus. We got the guess right. Now we go back to joint C, because we know the members closer to joint C. So we need to know at least one. If we have 3, we need to know one to know the other 2. So we know already force 2 from joint B, and force 2 from joint B plus the horizontal the horizontal component of force 7, it will be equal 0. They cancel each other. So that will give us force 7 equal W. So that means it was in tension, so the guess was right, it is in tension. So the sum of horizontal forces equals 0. So in joint E we have 4 forces. If you look to the example, we have 4 forces. Joint E here, this one. We already found the 7 forces we are looking for, so we reached number 7, but we go to joint E just as a check whether we did it right or wrong. So in joint E, force 7 cosine 60, which is the horizontal component of force 7, plus force 4, which is already in the horizontal axis, minus force 6 cosine 60, which is the horizontal component of member 6, minus force 5, the horizontal component of force 5 towards joint E. That should be equal 0. If we substitute all the values we have for this, then we did it right. We did it right. And then we go to the sum of forces vertically. Again, force number 6 sine 60, which is the vertical component of member 6, plus the vertical component of force 7, which is F7 sine 60 equals 0. Again, if we substitute that, we will find ourselves getting it right. So this is just to check it, the last steps. So this is the way you solve, you analyze structure using method of join, so analytically. Thank you for watching.